All right, so let's finish up the player and the platform collisions. So we got to change the way that we are interacting, how we're kind of building where the player is. We've been just defaulting where everything was on the bottom, but now we have this platform. We actually need to have our player and our enemies standing on top of that. And then we have to change how we are actually colliding and dealing with gravity. So all of our different states for a player is going to change, because once they're on the platform, we need to basically check if we're going to end up falling and hitting some other stuff. Okay, so the first stuff that we have our platforms being loaded. We do need to have a new function. So we do an init and push these platforms. And those platforms, ultimately for our player, we're going to have to pass those platforms. But we do need to have something to like load what we consider to be the floor of our enemies or wherever, because we may end up wanting our enemies starting at a higher height. We might want to eventually have them where they're tied to a different platform. So this is the way that I did it. There might be more elegant ways to do it. I'm going to create a couple methods. One is I want to pass in a platform, and I just want to return the platform.position.y, because the way that I'm setting these platforms is that this is their top left drawn, so that I know that the Y is going to be the very top of that platform. So that should make things ultimately easier for drawing my enemies. Okay. So we're going to do this for each one of the enemies. This height is now going to change for each one of them. Instead of me saying height and then minusing that, I am basically loading a platform. Now, which platform am I loading that I want them to stand on? The very first one that I pushed, that's why I did it, is ground. So I'm going to load the ground one. So that's platform 0. So I can say load floor. And then I'm just saying platforms position 0. That is my function, and then I'm subtracting 25 from it, and that's my height. So now, just running that, we should see a change in height for enemy 1, if I didn't make any stupid mistakes. So now he's standing up. So we're going to do the same thing for all of our other enemies. Yeah. Okay, so enemy 1, enemy 2, same thing. Instead of height. Oops, I guess I copied too much. Enemy 3. And then we'll do the player. Okay. This doesn't really solve it though, because our player is still kind of going down to the ground, but because we're not designing our enemies to be like that, they're going to reset as the bottom. Okay, so we kind of have it for our player, but we got to tweak some things. Okay, so one of the things that we could do is that our enemies and our player should all know what the floor is, the absolute bottom of the game. That way, if they fall off of it, if we have a gap in the ground that we have not done, we should be able to have them all, basically fall to their death or whatever. So since we want to do this for all of them, we need to go to dynamic creature, and we're going to play around in here. So I'm not really changing any of these methods. I'm just going to add a little bit of stuff in here because everything else is working. I just want to start tweaking some things. So we're going to add a reference to floor. We'll set it as null when we initially create, and then we're going to create a function called load floor, and we pass in a platform. That way, if we wanted our enemy to be on a different floor, we could load a different floor. This dot floor is the platform dot position dot y. Okay, simple enough. Now in our sketch, let's go back and we're going to apply that to all of them. Okay, so let's go back to enemy 1. All right, so enemy 1 dot load floor platforms 0. That's the bottom that we're doing. So I'm going to copy this. Enemy 2, load that. Enemy 3, load that. And then player, I'm just checking my notes. Yep, okay. And then for our player, so that will at least give us a reference to the floor for everybody. But ultimately, since these platforms, I want my player to be able to dynamically jump on them, fall off of them. My player is going to end up having to have reference to those platforms. And then that would allow me to know, what's happening. I can check those list of platforms a lot easier. So the player is going to end up having to change to be able to get references to those. So we have an enemies list. We're also going to do a platforms list. So this dot platforms list is an empty set of brackets. Okay. And then we're going to have to create a function for this. I'm going to put it close to like my load enemies. Where is that at? Load enemies list. Load platforms list. Load those platforms. This dot platforms list equals platforms. Now, if this is something that I wanted all of my enemies to know too, and I wanted to design the enemies to be able to, say, walk on a platform and then fall off, I would probably move this then into the dynamic creatures class, because then I can access that anywhere. Okay, so let's go to our player. So right in our setup, after we've created the platforms, created the enemies, so here, we've loaded the enemies to our list for our player. We also want to do that same thing for our platforms. So now that we have that, we can do player.load platforms list platforms. Okay, so we pass those. We now have that. That's not really changing much yet, other than our enemies are starting where we want. They have the same bottom. When they walk, we should see them also stay on there. Wow, why is it taking forever for you guys to do something else other than idle? anyways. Looking at our idle state, we could leave it go. We got to start changing some stuff. So let's go to idle. Our reset position that we did, now we can actually access our floor. Which would be here, instead of just doing this. Why did I do it that way? Hold on. We loaded the floor. Okay. All right, so we go to our idle state. We're going to want to change this. This dot subject dot floor. Okay. There we go. Now that's on the top. There is a couple things that, so when we switch positions, we're now back at the ground. We're going to have to make some changes onto that. We're also probably going to want to change our foot sensor so it's actually touching right at the top, or excuse me, right where our feet are. It's going a little bit below. So we're going to want to tweak some things on that. But for idle, there isn't really much else to do. Everything else is basically the same. When we go into run, this is where we're going to have to start making some big changes. Because when we're running, we don't actually want to reset position, because we may be running on a platform and we want to fall. So we're going to make a couple changes. I'm going to comment this out so that now when we're going from an idle state to a run state, which now when I'm doing a jump, it's going to mess up. But so we're going to slowly get there. We want to do a run state. So let's do, I'm going to go to my player and I'm going to change him to a run state to start off. Player. So initial state, let's do run state. Okay, so now he's running. If we jump though, that's a different state. We need to have it fire appropriately. Okay, so we have him starting at the top. That's where we want, because that's where we're just kind of defaulting where his floor is. But we're going to have to change some stuff in the update. Okay, so the update up to now wasn't really doing anything, but now we're going to have to check if we are colliding with our foot sensor. Okay, so that foot sensor needs to let us know where we are, and then if we have a collision, then we're going to end up choosing that as like our new floor. Okay, so here, the way that I wrote this is that we are basically creating some type of switch state flag, and we'll set it as true. Like, we want to switch unless our foot is colliding with a platform. Okay, so we want to switch to, and we'll just have it default to the dive state. We could separately create another fall state, but the dive state we're just going to modify to do a bunch of the things that we want to do, including coyote jump and stuff. So what I actually want, I want when I jump that I normally come down at a slow speed. But if I am on a platform and I fall, I want myself to actually fall quickly. I don't want to have a floating effect. So I do want to almost just default call the dive state, but then I can still call the dive state from the jump when I'm not touching a platform. Okay, so that's what we're going to kind of do. We're going to start defaulting to calling it the dive state. So we're going to default always want to change to a dive state unless we have a collision. So that's why we have it setting like this. So we're going to say for let platform of the platform list. So this dot subject dot platforms list. And we want to check each one to see if we have some type of collision. So if this dot subject dot foot dot collided with the platform, which we got to rewrite that. If that's true, then the switch state is switched to false. Okay, and technically, then we don't need to check anymore in here. So if we have collided, then we can break out of that list for that one. Okay, now if we've made it through this whole thing, and we still have a true on our switch state, then we need to default call a new dive state. Okay, so return new dive state. This subject, and it is poppable. Okay, so this is how we're going to set it up. We're default wanting to call the dive state, and only when we collide do we say, nope, we're not going to do it. So if I'm on any one of these platforms, I need to generate it. Okay, now, we went through and we did a library for the sensor for colliding. Let me just go to that. Okay, but the issue is that when we are colliding, we are still just using a normal distance function, and this is going to be problematic. We need to actually collide against a rectangle, and we have pretty much all the stuff that we need to do it. The only thing that we really need when we're checking for what we're colliding is that we need to know if we are a platform or a ground, then we are going to collide a different way. If we're anything else, then we're basically doing the distance function between these circles. So the sword and the radar, the sword and the head, the sword and the body. So this is what we kind of want to default do. And then we're only doing special cases. So I'm going to say if object.type is not equal to platform, and object.type is not equal to ground. All right. If that's the case, then that means I'm default doing all of this. What? We're default doing all of this. Okay. If it's not, so that means anything else, a ground or a platform, we want to have a different type of collision. We want to basically, I'm going to write this a little bit more simply. We could also rewrite this too. That really all we're doing is when we're checking these, so this distance, if this is true, this would return true, or it would return false. I could rewrite this whole if statement and just say return and then ask that question. So what would that look like? Because this is kind of how I'm going to modify my other stuff. Instead of saying if this or this, this is going to return true or false already. So I can, instead of saying this, I can comment that out. And I'm basically just doing this as shorthand. I just wanted you guys to understand. So I'm asking this question. That's going to return true or false. And there's my collision. Okay. Now, in here, we're doing the same thing, but we're going to be checking off of a different type. So collide, rect, circle, vector, collision, which needs a few pieces. We are going to have for our platform, what am I doing? This dot position is my sensor, and then I'm passing in. I had to play around with this to have it go off a rectangle instead of a line because it kept skipping over. Yeah, so we're colliding with the foot. Why did I do it that way? I might have to tweak this. Object.position, okay, is going to be the position off of that foot against the platform. And then we have to have, because we're using vectors, we need to have position vectors and size vectors. So this next part right here is the create vector, and I'm doing it off that object dot width, and then I'm giving it, so that's how long it is, but then for how deep, because I'm not going to do this total thing right here for either of the platforms. So I'm letting it extend down 30. Yeah, okay. No, it's right. Okay, and then for my foot, that's my next piece. That's this dot position, because I already have that, and then this dot size, because it just has a diameter. Okay, that's going to return true or false. But now it's colliding my foot sensor against the rectangle. Okay, which will change some things. So when I run this, it's going to wig out on some things. Collide rect circle is not defined, and it's probably because we didn't import the library. Okay, so the libraries, when we come in here, we're going to do collide 2D. Because this, I mean, we could manually do this, it's just, this is so much easier. We want to copy this piece of code right here. And this is just for us to import a library. There's a whole bunch of different options that we can do. As long as you're importing the library after P5.js, there should be no issues. But this is really built off of this. This piece of work, he collected all of the different collisions. As long as we're not rotating, we don't really have to worry about a lot of things. So in this one, we're doing a circle versus a rectangle. Okay. So basically, we want this to show that there is some collision on either of the sides. And really, we're using the distance function like we would, but we're overriding some things with the values plus the radius of the circles when we're dealing with corners. So if we look at it in such a way that all we need to know is, did we collide or did we not collide, then we can use these. They're a little bit faster to use. Okay, so that's ultimately what we're looking at. But this is the code. We're checking each of the individual edges, and then if we're a certain distance away, then we're defaulting to the corner against the circle. Okay, but we did not import it yet. So as long as it is after P5.js, we can load that. So I did. That should actually fix the error. I know it's working because I see it there, but I have other errors. Cannot read properties of size, sensor 53, this dot size, and that is, let's just see what that is. So this dot console.log, this dot type. That's the foot sensor. Okay. And I probably made some stupid mistake. So let's look at the player to see how I set that up. Foot sensor. I do have a size. Size. Okay, that one has a size. Let's see. Object.width 30. That might be the size that it doesn't like. Let's double check that I'm building this right. Circle rect. We're doing a vector, so it's the rect start, rect size, mouse, and radius. This is centered, and we're doing the corner. So rectangles first, and then it's the circle. Rectangles first. Let's look at the object. Ground, vector, velocity, dynamic. We don't have a size yet. Okay. I don't have a size, but I gave it a size. Platform. Yep. Platform inherits from dynamic. And I want to set length, images, size, width. Don't make any changes to this. Oh, right there. Object.width. I got that. Do I have width? Object.width. $1,000. Okay, this.position. There. Stupid error. I made a writing mistake, comma. All right. Okay. So now we have that collision. We've made those changes. I'm still kind of falling back down. I got to reset that. But that would, so that fixes our run. Now, we have not imposed gravity on other stuff though. Once we get to a platform, we need to set that. So we've done idle, we've done run. Let's do jump. This one's going to be a big one. Okay. So we have gravity. We're changing, we're adding our strength. If we wanted to change the radar of what's happening, we would do that here with our sensors. Just double checking my notes as I'm going down. Okay, so let's start with the update. Okay, we add gravity and then we have it when we're hitting the bottom. When our bottom is there, then we're generating the run state. We want to actually trigger this differently. So here, we're going to do this different. We don't want to run that the same. So we're not going to have it hit like that. We're still going to do a switch state. We'll start it out as false. Now this is when we are jumping, okay? I want to have my platforms be null, and then basically if we are increasing in velocity, that means that we are coming down. So when we are jumping, when we're going up, we got a negative velocity. When we're coming down, we got a positive velocity. That's when I actually want to start checking for when we need to have some type of collision with the platform. So if this.subject.velocity.y is greater than 0, if that's the case, then we're going to look through the platforms, and we'll look through our enemies, because we also want to add a double jump on here too. So let's go through the platforms first. So let platform of this dot subject dot platforms list, if there is one. So if this dot subject dot foot dot collided a platform, then we want to switch that switch state, and our platform position is going to equal that platform. And I think I actually want to switch this during the exit. So I'm going to make this more of a global. I'm going to switch this around. Let's put that here. This dot platform position. When we create it, we will do okay. It's null when we create it. And then we can change it here. So that's where we will reset our player's position. So if we are doing a switch state, ultimately we are going to be running a new run state. But as we're exiting, if there was a switch state, that's going to be that new position that we are. So if switch state was true, then this dot subject dot reset position, null on the X, platform position, whatever that is, dot position dot y minus this dot subject dot radius. We could play around with the bottom, stuff like that. That's fine. So that's when we exit. And in our update, if this was true, so we have gotten all the way down somewhere here. Yeah. If we've gotten here, if switch state is true, then we're going to return a new run state. This dot subject, and it's going to be false. Okay. Or, well, this one could technically be true. That's fine. We could reset the position before we return the run state here, but I'm having it in the exit so that we know that that's only getting called one time. Okay, so let's see what that's going to do. Oh, this dot. Platform position is not defined. 153. Awesome. This dot. Love it. Jump state line 22. At this dot switch state. All right. Getting overzealous. There we go. All right, so now we got a collision. That goes to our run state. That's correctly working. There are a couple tweaks that sometimes it seems like we're missing stuff. So here I'm falling. So we're going to continue working on the things, hitting the other states, because that's some of it. Okay, all right. Let's add the double jump in. Okay, so if our velocity is increasing, okay, so that's here. We want to basically check all of our enemies now that are dynamic. Okay, so for let enemy of this dot subject dot dynamics to check. If our foot collides with this, so for let sensor of any of the enemy sensors if our foot collided, sensor then we can trip our foot. So this dot subject dot foot dot set tripped, and we'll set it to true. Now you could be very specific on this. You can make sure that the foot is the only thing that's colliding, but since the foot is smaller than the body or the head, you'd hit the head or the body first and we would be reacting. What we're wanting is when the foot is colliding with an enemy, then we can add in a double jump. So we are using this to trigger that the foot has been tripped, that sensor, which then means that we can come back up to our handle input, and now we can tweak this. So this right now we're looking for when we're pressing the key for jump and we're in the jump state that we are changing gravity, but now we're going to actually change this. And while we're here, key is down is actually a better one than this. So key is down and we're doing 32. Okay, now if that's true, then we're going to come here that we press the space bar. We want to check, do we have a triggered foot? Subject.foot.tripped. If that's true, then we can set the foot to no longer be tripped. So this dot subject dot foot dot tripped, or set tripped, is false. Okay. And then we can return a new jump state. This dot subject comma true. Okay. Which would allow us, now it's going to be a little bit harder to test because we also got platforms colliding, but we should be able to double jump off of an enemy. We got to be in a jump state to do it though. So if we wanted to do it from a dive state, we got to make some changes. Okay, so this one, if you're wanting to try to test this, you might have to take off the platform so you can see it. At least the other platforms, the bigger platforms, not the ground platform. The other thing that we want to do is that we need to add some coyote jumping that we don't have yet. Okay. So, I mean, really the collision for doing this for platforms, most of that pieces is done. We do have a double jump using the sensor. Again, we are maybe wanting to tweak that sensor just a little bit. But we can interact with the platforms. The dive state is the next one that we're going to want to play around with. It should be... yeah, I'm just double checking the jump state one more time. That's good, that's good. Yeah, okay, so the dive state, let's go back here. Dive state, we want to add, we got gravity working, for us. We also want to add the coyote jumping. So that means that we need to have a little bit of a timer. So we're going to do coyote start time, and that's going to be set. We'll use it to take some time from when we create it. So we create the dive state. As soon as we start falling, we go into the dive state. Whenever we go into dive, we also go into a dive state. So that would start the coyote start time, and then we want it to be short. This would be the time that we could do. So 250, this is in milliseconds. So right now I'm setting this as like a quarter of a second. We have a quarter of a second reaction time to be able to play around with our stuff. Now when we go into a dive, because we're having this happen multiple different places, we're going to have to make a little bit of changes. We want it to be able to switch into the jump state, because this going from here, we don't want to keep running. We want to transition to a dive. Okay. So we want it to look like that. We also want to space out our handle input. So in here, we're going to create a timer that's based off of the current time minus the Coyote start time. Okay. Now, if that timer is, less than, say, that Coyote time, then we want to generate that we could hit, say, the space bar to jump again while we're in a dive state. But we do not want to do that while we're pressing the down key. Okay, so we're going to say key is down 32 and key is not down for 40. That should be the down one. And the elapsed time that we just calculated is less than the Coyote time. Okay. If it is, then we could return a new jump state. This dot subject dot comma true. Okay. The reason why we're doing this is that we want to give a little bit more reaction time when we're on the platforms to react to be able to jump off. So when we're falling, we can still jump. Oops. There's a bug in there. He's jumping way too early or too high. There. That was that. Okay. So we can fall a little bit and we can generate in a dive state when we've hit a platform. We get a little bit of that Coyote time. Okay. Now, so that's just a Coyote jump. That's kind of small. We want to come to here and we want to be able to change when we are falling. So here's the other piece that we have not fixed yet. When we're falling down in a dive state, we want to generate that we fell and we want to fall on another platform below it. So this needs to get changed right here. So I'm going to comment that out. We're going to do the kind of the same thing. So since we're changing our platform position in our switch state, let's bring it up here. So we're going to say this dot switch state, this dot platform position, and that's going to equal null. We'll start this out as false. Okay, and then when we get into an update, we're going to further make sure that we're in there. False. Okay, so we're going to go through every platform. For let platform of this dot subject dot platforms list. If this dot subject dot foot dot collided that platform, if that happened, then we want to switch the state. So switch state equals true. Then we're going to return a new run state. This dot subject and false. Okay, or true. Either one would work. Okay, but once we go to call the exit, Right now we were exiting and resetting the position. We don't want to do that now. We want to reset, call the reset position, and then call based off that new platform that got triggered that we collided with. Okay, so this would be calling that reset. This subject.reset position, null for the X, and then it'd be this dot platform position dot position dot Y minus this dot subject dot radius. Okay, that should be the bottom of our stuff. Now when we are falling from one to the next, my jump is way too high now. Okay, let's watch falling. Ooh, that was awesome. 924, what did I do? This dot platform position equals that platform. Ooh, there we go. Okay. I'm pretty sure that there's still a couple bugs in this, but this is kind of the idea. There we go. We're not triggering on the bottom. That ground is getting flagged. It is still possible for you to clip through stuff if you're falling too fast and the foot sensor is not triggering inside of that area. There's a number of ways that you guys could tweak this to make it so that doesn't happen. You should not be able to jump to that third platform. So once you guys get your stuff set up, yep, there was an error. You're going to want to adjust your speeds to make it so you're not able to clip through, or your rectangle that he's colliding with, he should not be able to fall through that within that fall time. So I tweaked mine on my jump strength and all of that stuff. My jump strength I put down to, I also played around with the gravity for him so that wouldn't show up as easily. Gravity I put down to 1. Dive state I think I had it at 2. His jump strength was 15. Dive 2. And then I didn't reset gravity there. So you can just kind of tweak stuff, but because he's going slower now in that frame count, it would still trigger correctly. What? That was weird. I can still hit down to fall faster. Oh, there it is again. I haven't had that error come up before. Yeah, so just double check your stuff. But that's the idea. If you guys are seeing that error come up, I'll look through it and try to figure out what it is. But that basically finishes off the collisions with platforms. For the enemies right now, we are just defaulting them walking on the ground. But if you wanted to actually check and have the enemy, say, fall here at the top before they actually come into the screen, so that they could fall onto a platform, that is something that you could do and have it actually do the same thing where it is checking the platform list and having them fall. You'd have to institute and then check for collisions to see if they're actually hitting something. So you could do that too, and if you were, you might have to institute a foot sensor for them as well. But that's how you would add that functionality. Okay, so that finishes off the player colliding with platforms or enemies colliding with platforms. The next one would be for the shurikens and being able to build those and do those. All right, good luck. Have fun.